Hello everyone and welcome to MBK. Today we are going to learn how to reduce fractions. Um, it's going to go into a little detail. We're going to talk about primes and factors and all that good stuff and how to break down numbers into their prime factors. And knowing how to do that will make reducing fractions a lot easier. Um, the first thing I like to tell people is to memorize at least the first couple of primes up to like 20. What I mean by that is all the primes that are in the numbers 1 through 20. So it's going to be 2, 3, 5, 7, 11, 13, 17, and 19. Knowing these will help you break down numbers into their prime factors, and I'll show you one method to do it. And let's get started. So the first problem is going to be very easy. It's going to be reduce 4/8. Right off the bat, I can already tell you that it's 1/2. But how do we already know that? Well, we know that 4 will go into 8 two times. But let's do it with prime factorization. So we're going to have to break down the numerator and the denominator into its prime factors. So let's start with the 4. The way I like to teach people how to break down numbers into the prime factors is by writing the numerator right here in the little bracket, and we ask ourselves, what is a prime number that goes into 4 evenly? Well, 4 is an even number, so we can say 2 will go into 4. How many times? 2 times, because 2 times 2 is 4. Then we do another bracket, and what's another prime? Well, 2 is already a prime, so we know 2 will go into 2 one time. When you get to 1, you know you're done. So right here we're going to write a 2 times 1. Where did I get these? Well, 2 times 1. Let's do the same thing with 8. 8, a bracket. What's a prime number that goes into 8 evenly? Well, we know 8 is an even number, so we can already start with 2. 2 will go into 8 4 times. Well, 4 was already right here, so we just forget the rest, but let's do it anyway. 2 will go into 4 2 times, 2 will go into 4 2 times, and 2 will go into 2 one time. So when you reach 1, you know you're done. And we just write these numbers, we multiply them all together up here. 2 times 2 times 2 times 1. So, what's 2 times 2? Well, that's 4. 4 times 1 is 4. And what's 2 times 2? Well, that's 4 times 2 is 8 times 1 is 8. However, that's to show you that this is like the fingerprint of this number right here. So let's divide the numerator and the denominator by all common factors. So 2 will cancel this 2, and this 2, and these 2 cancel each other. So we're left with 1 over 2 times 1. Well, what's 2 times 1? Well, that's 2. So the answer is 1/2. Notice that this 1/2 is the same as this. Okay, let's move on. Let's do another problem. The problem is going to be 3 over 9. Let's do the same thing we did here. We'll write a long bar. So 3, put a little bar, and 3 will go into 3 one time, right? Because 3 is a prime number, it's right here. Okay, so it's going to be 3 times 1. Remember, when we get to 1, we're done. So let's do the denominator, so 9. So we know this is not an even number. What's the next prime number beyond 2? Well, it's 3. Unless you already know your times tables, you can just kind of go, well, does 2 go into 9? No, it's not going to be a whole number. Well, we know 3 goes into 9. 3 goes into 9 3 times. 3 goes into 3 one time. And when you reach 1, you're done. Sounds kind of dorky, but it'll help you remember when to stop. Okay, so 3 times 3 times 1. Okay, so we just cancel these 3's, and we're left with 1 over 3 times 1, and that's going to be 1/3. That's our answer for that. Alright, so let's rewrite our prime numbers, at least the first couple of ones, just to help us out. It was 2, 3, 5, 7, 11, 13, 17, and 19. Okay, so the next problem on the agenda is 10 over 12. 10 over 12. Okay, so you see I'm going a little quicker now. I hope I'm not going too fast for you, but I want to do as many of these problems as I can in around 10 or 15 minutes. It just depends how quickly we get through them. Anyways, so 10 into 12. Not into 10 over 12. So let's do 10. 10, a little bracket. We know 10 is an even number, so 2 will go into 10 5 times. Is 5, by looking at our list here that we made, we know 5 is already a prime. So 5 will go into 5 one time. Okay, so it's going to be 2 times 5 times 1. Okay, now let's do 12. 12. Okay, so we know 12 is an even number, so 2 will go into 12 6 times. 2 times 6 is 12. Well, right here we have a choice. We can either use 2 or we can use 3. Let's do 3. We know 3 will go into 6 2 times. 3 times 2 is 6. And let's do 2. We'll go into 2 one time. And once you reach 1, you're done. So 2 times 3 times 2 times 1. We could have also gone like this. I'm going to show you a couple of ways we could have gone about doing this. Let's start with 3. Let's say we didn't know 12 was an even number, but we remembered our times tables and we remembered that 3 times 4 equals 12. Okay, so 3 will go into 12 4 times. Okay, well, we know 4 is an even number, so 2 will go into 4 2 times, and 2 will go into 2 one time. Okay, and there's a couple of different variations of this. I'll just focus on these two. So I'm going to write the prime numbers under these things, and you'll see what I mean. 2 times 3 times 2 times 1, and this one was 3 times 2 times 2 times 1. Okay, so let's multiply these. What's 2 times 3? Well, that's 6. And what's 6 times 2? Well, that's 12. So I'll write it down. 2 times 3, that's 6, right? 6 times 2 times 1. 6 times 2, well, that's 12. 12 times 1, and you know that that's 12, right? Well, let's do it this way. 3 times 2 is 6 times 2 times 1. 6 times 2 is 12 times 1 and 12. See how they gave us the same answer even though the numbers are out of order? With multiplication, order, as long as you're multiplying numbers, order does not matter. Okay, so we could have rewritten this like 2 times 2 times 1 times 3. All of that, once you multiply it all out, that's going to equal 12. You should try that on your own and see that it's correct. Anyways, let's go back to reducing this problem, reducing this fraction. Okay, let's cancel the 2's, and that's all we can cancel. So 5 times 1 is 5, and I'm just going to rewrite 3 times 2 times 1. Well, 3 times 2, let's rewrite the 5. 3 times 2 is 6, times 1 is 6. And that's our answer, 5 over 6. Okay, so let's do 8 over 14. 8. We know, let's put back our prime numbers. It's going to be 2, 3, 5, 7, 11, 13, 17, and 19. Okay, so we know 8 is an even number, and we know that 2 will go into 8 4 times, because 2 times 4 is 8. We know 4 is an even number, so 2 will go into 4 2 times, and we know that this is just going to be 2 into 2 will go one time. So our numerator is going to be 2 times 2 times 2 times 1. Let's do 14. 14. Well, let's, we know 14 is an even number, so 2 will go into 14 7 times. 2 times 7 is 14. And 7, well, we already know 7 is a prime number. It's right there. So 7 will go into 7 one time. So once you reach 1, you're done. 2 times 7 times 1. Well, let's cancel everything that's the same on top and bottom. And we're left with 2 times 2 times 1 and 7 times 1. Okay, 2 times 2 is 4. Any number times 1 is that number, so we know it's going to be 4. 7 times 1 is 7, and that's the lowest, that's the fraction reduced. Let's see, 16 over 18. 16 over 18. Okay, 16. We know 16 is a even number. 2 will go into 16 8 times. 2 times 8 is 16. Earlier we did the 8, is the problem up here. So we can just copy this basically, 2 times 2 times 2 times 1, and not even have to do the rest. But we'll do it for this problem just to see, to get used to doing it. So 2 will go into 8 4 times. 2 will go into 4 2 times. And 2 will go into 2 one time. I'm running out of room here. So all we do is we multiply these on the numerator bar. So 2 times 2 times 2 times, how many were there? 4? 2 times 1. 2 times 2 times 2 times 2 times 1. Yeah. And let's do 18. I'll do it right here because I think I'm going to run out of room. 18. We know 18 is an even number, so 2 will go into 18. What number times 2 will equal 18? 2 times 9 will go into 18. 9 times. Not 9. Prime numbers for 9. 3. 3 will go into 9 3 times. 3 times 3 is 9. And 3 is a prime. So 3 will go into 3 one time. Oh, that's a horrible 3. I need to redo that. Oh, there we go. Okay, so we just write these numbers. These are our factors, and we can just write them on the denominator line in the denominator place. 2 times 3 times 3 times 1. Now let's cancel everything that's the same on the top and the bottom. Right? And is there any 3's on the top? Any 2's on the bottom? No. Okay, so our answer. Our answer is going to be 2 times 2. Oh, I'm sorry, that looks horrible. Our answer, man, there's really no. Okay. Our answer is going to be 2 times 2. Well, that's 4. 4 times 2 is 8. So it's going to be 8, and 8 times 1 is 8. And then 3 times 3 is 9, times 1 is 9, and that's our answer. Okay, let's run out of time here. I got time for maybe 2 more problems. And let's do 14 over 21. Okay, this one's, our primes. 2, 3, 5, 7, 11, 13, 17, and 19. Okay, so 14. 14 is not a prime. We know 14 is an even number, so 2 will go into 14 7 times. 7 is already a prime number. 7 will go into 7 one time. So 2 times 7 times 1. And let's do 21. Okay, so 21. Well, we know 21 is not an even number. 3 will go into 21 7 times. 7 is a prime, so we can just do that. And it's going to be 3 times 7 times 1. So it looks like 7 is the only common factor here, and it's going to be, the answer is 2 over 3. And that's it for the video. Thank you.